Well, hello there guys, Mr. G here, and we're going to be making another video on vertical projectile motion for the grade 12. This time we're going to be solving more questions, and we are going to have two questions. The first question said that a supervisor who is 1,8 meters tall visits a construction site. A block resting at the edge of a roof 50 meters above ground suddenly falls. At the instant the brick has fallen 30 meters, the supervisor sees the brick coming down directly towards him from above. Ignore the effect of friction and take the downward position as positive. This is something that you cannot change. Take down as positive. So for the whole question, down must be positive. Calculate the speed of the brick after it has fallen 30 meters. The average reaction time of a human being is 0.4 seconds. With the aid of a suitable calculation, determine whether the supervisor will be able to avoid being hit by the brick, and draw the velocity times graph for the motion of the brick. Now, note the following. This we are going to be having a video related to just graph. However, we are going to be doing this one because you learned graph in previous grades, so it shouldn't be a big issue here. Alright, so without taking longer, let's first of all have a quick sketch to see the situation of what we have. Okay, so this is the sketch which I'm please telling you that it's not done at scale. Okay, so there is a building site which is 50 meters high, and then from that point there you can see a brick that falls down, which means the initial velocity is 0. A person who is 1,8 meters high, obviously you can see it's not at scale. Since a brick somewhere when the brick is already 30 meters down, so the brick is already 30 meters from there, it has fallen 30 meters. In this case, this here will be the displacement, which is 30 meters. So let's write here displacement for the first question. Well, let's just keep the 30 meters and let's see the question. Now, question 1.1, they said calculate the speed of the brick after it has fallen 30 meters. So let's quickly write the data we have, and remember down is positive for the entire question. Okay, so saying that, what do we have? What data do we have here? First, the initial velocity is equal to 0. Second, the displacement when it has fallen 30 meters is going to be equal to 30 meters, and it's going to be positive because down is positive, and the displacement, as you can see there, is also positive. What other data do you have? The acceleration due to gravity is equal to positive 9.8 meters per second square, and then this is all you have. You are looking for the final velocity of the brick when it has fallen that distance. So from this data, which one is the best formula we can use? The final velocity square is equal to the initial velocity square plus 2 times the acceleration multiplied by the displacement, and this is the formula we are going to use. If we substitute, note they're asking you to calculate the speed, so it's no direction needed, and this is the first question. It's quite easy. The second question is a little bit more tricky. Okay, so this question says the average reaction time of human is being 0.4 seconds. With the aid of a suitable calculation, determine whether the supervisor will be able to avoid being hit by the brick. So note the following in this specific question. The supervisor sees the brick when it's at this specific point there, and it reacts only after 0.4 seconds. So in other words, we need to know how far that brick will fall in 0.4 seconds from there, or we have to calculate the time the bricks will fall in 0.4 seconds to see if that person will avoid the brick. So what we are going to do, we are going to calculate how far will that brick fall from there. How far will that brick fall from there to see if the person will be able to avoid the brick. So we're going to calculate the displacement as from there, as from here. How far is that block going to fall? All right, now this is question 1.2. So if we use that one, the best formula is displacement is equal to initial velocity. Remember, we're going to see from there. So the initial velocity will be the velocity we have at that specific point, multiplied by time plus half acceleration time to the power 2. Okay, and we're looking for how far is it going in 0,4 seconds. So when we substitute here, okay, now we know how far does the brick move in the 0,4 seconds. Okay, so now let's see how far the brick did move since the moment it fell. So it will be 30 meters plus the 10,484. So the total displacement 40,484 meters from top. So if we go to the picture, that means that the brick move from top to bottom. Let's say this is the bottom of the construction site. This is 50 meters, and the brick from here moved down 40 meters, 484 meters. All right, all the way down, and the man is here down. How tall is the man? This man is going to be 1,8 meters. So if we subtract 50 minus 40,484, then we get 9,516. So it means the brick still did not arrive to the person, and the person will be able to avoid the brick. So that is the answer. We must write that one. So you say he will not be struck by the brick still few meters above his head. So this is the question. It's not that bad, it's a little bit tricky, but not that very bad. So let's do the final one, which is the graph. And remember, we are going to make videos just on graphs, but let's look at this one because it's not that bad, and we already learned graph in previous grades. Okay, so first of all, remember, when you have graphs, you have to draw the axis. Okay, this is the axis. Okay, so the brick start moving from 0. Now this is velocity versus time graph. As I said, we want to be looking at that one, but be careful. The brick start moving from 0 because it's dropping, or it's being dropped. So the initial velocity is going to be 0, so it is here. And because the brick is moving down, the velocity is going to increase positively because down is positive. It means that after some time, and we're not going to put any values here, we're just going to draw a shape. Okay, after some time, whatever the time it is going to be, the velocity must have increased from 0 to any number there. So if we do that, it means that the object must be somewhere with time a little bit there. So the velocity increases from 0 to the value at that point, and I'm saying this is going to be just a drawing, not numbers needed. We are going to later on have a video on just graph, but this is the first question, guys. I hope you understand. We are going to do another question right now. Okay, here is the second question. This question said, Sandile, who is standing on a platform, throw a small ball, a metal ball of mass 10 grams vertically upward from a height of 1,73 meters into the air at 8 meters per second. The ball accidentally lands into a gutter of a building. It remains in the gutter for 0,5 seconds and then falls through a hole in the gutter back to the original position in Sandile's hand. Ignore the effect of friction and any horizontal movement. And here is the picture of what we have there, so we don't have to draw the situation. With what speed will the ball have fallen into Sandile's hand if the ball has not fallen into the ground? Using equation of motion, calculate the maximum height that the ball reaches above the ground And if the gutter is at a height of 2.5 meters above Sandile's hand, calculate the speed with which the ball lands in Sandile's hand. Now, important. The first one here is really fast. If there was not a gutter, the whole motion will go moving up from release point and coming back to the same position there. And remember the magnitude of velocity we spoke about. So if the initial velocity is going to be equal to 8 meters per second upward, then the final velocity there at that point will also be 8 meters per second but downward. But now, important, this is only if there were nothing on the way. In this case, it's not the case because you have a gutter there, you have something here that is having contact with the object. That is why they're asking here in the question, if what will the speed be if there was not falling into the gutter. So if it was not falling into the gutter, then the speed here would be 8 meters per second, no direction, because they don't want a direction in that question. They're just asking for the speed. So if there was not this gutter here, then the ball will reach Sandile's hand at the same speed at which the Sandile throw the ball up, which is 8 meters per second. So please note, this picture I have here on this side is only if there was not a gutter. Okay, so I'm going to write it there. If no gutter. Okay, so now carry on. Using equation of motion, calculate the maximum height that the ball reach above the ground. So we have to calculate the maximum height above the ground. And note that some numbers are given in this picture, but we are going to ignore those numbers and we are going to calculate the maximum height. So the first thing we're going to calculate is how far the ball go from the released point. Remember, release point is not on the ground because this person is already standing somewhere and it's some height from the ground. Okay, so but he throw the ball, so let's calculate how far from the release point is the ball going to reach upward up until the maximum height, and ignore all these numbers here on this side. Okay, so now how do we calculate the maximum height? Let's first of all, as we always do, is write the data of what we have. Okay, so what data do we have? First of all, initial velocity is equal to 8 meters per second. Remember, we have to select direction. So we're going to say in this question, upward is positive. Up is positive just for perhaps this one here. Okay, so up is positive, please, is important. Now, if up is positive, the initial velocity is positive. At a maximum height, the final velocity will be 0. That is what we have. The what else? Acceleration due to gravity is going to be equal to minus 9.8 meters per second square. This is square here, minus, because I say up is positive. Okay, and we are looking for the displacement. So we're looking for how high is the object going to be moving, which in this case is going to be the displacement, and the displacement must also be positive. Okay, so according to this, what formula can we use? So according to this formula, we can say that the final velocity square is equal to the initial velocity square plus 2 times the acceleration multiplied by the displacement, and we are looking for the displacement. Okay, so let's quickly substitute and let's see what is the answer. So the answer here is 3.27, but it's not above the ground. Remember, the question asks to calculate the maximum height above the ground. So the maximum height above the ground, the maximum height above the ground would be the addition of the would be the addition of the 1.73 height from which the ball was thrown plus the maximum height we reached from the throwing point, which is 3.27, and then this is going to be equal to 5 meters. So that ball reached 5 meters above the ground. Okay, now 5 meters means from starting point node from the crown to the maximum height. This point is 5 meters above the crown. Okay, so that is the question, the first question, which is quite simple. It's not that complicated. All right, now the second question say if the gutter is at a height of 2.5 meters above Sandile's hand, calculate the speed with which the ball lands in Sandile's hand. Let's fix that name there, in Sandile's hand. And now for this question, we are going to be using when the ball is falling from the gutter. So this is 3.3. Okay, so if we say that, now we have the new data. The initial velocity now is going to be equal to 0. That is the moment the ball drop or fall from the gutter. Okay, we have to look for the final velocity, which is at his hand. Final velocity, which is at his hand. That is going to be the question mark. The displacement is also given to us equal to 2.5 meters, and we have the acceleration due to gravity, which is 9.8 meters per second squared. We are going to take in this question down as positive. Remember, I told you can change the direction from question to question. Okay, you cannot change it in the middle of this sub question, for instance, but you can change it. Okay, so now here we are going to be calculating the final velocity, and we're going to use exactly the same formula. That is the velocity with which the stone or the ball reached Sandile's hand. So guys, this is very easy, this question. I hope you understand. I hope it helped. I'm sorry for the delay of the video. Next time we're going to be talking about graphs. But thank you for watching. Subscribe for the channel. Thumb up. I'll see you next time. Mr. G here.